So we've done some review of factoring. I also want to do review of the quadratic formula. So we've been looking at the different forms of a quadratic. So we've talked about standard form, factored form. We briefly touched on vertex form. So I'm just going to review that guy quickly, and then we're going to get into the quadratic formula and how we can use it, what it gives us. So in vertex form, this is called vertex form because it tells us the vertex. Can somebody help us with the vertex of this? Thomas?
It's 1 and 5.
It is 1 and 5, and we get that from this value and this value. So switch the sign of the value in the bracket. Axis of symmetry, we didn't touch on this yet. Does anyone remember how we do this? Thomas?
Well, I know what it is. X equals 1.
Yeah, so it's just x equals the x coordinate of the vertex. Perfect. Direction that this quadratic opens. Why upside down, Lauren? Okay, so we get that from the -5. Tells us that the quadratic opens downward. And how do I find the y-intercept? That is only actually when it's in expanded form, then we can use the c value. So we have to do something different when it's in vertex form. Anywhere on the y-axis, what is x? What is x anywhere on this axis here? It's 0. So can we just set x equal to 0 and solve for y? Okay. So we're in function notation here. We're going to evaluate f at 0. And then Thomas, what did you say you get?
0, 0.
Is it? Are you sure? Oh yeah, you're right. Perfect. So we get the point for the y-intercept as 0, 0. He was right. Okay, so plug in 0 for x, calculate, then you'll get your y. Okay, so that's just a quick recap of vertex form. So we're going to go into the quadratic formula here. So yesterday we talked about factoring. Factoring helps us switch from standard form into factored form. And if we can factor, then from factored form we can actually see the x-intercepts. Now the quadratic formula is kind of like if there's no option for me to get from standard form into factored form, I have to use the quadratic formula to find the x-intercepts. So we're going to do a recap of what that is and how we use it. And then we're going to apply this to some new grade 11 stuff in a few days. So just as a reminder, your quadratic formula is this formula here.
So much writing.
Okay, does anyone remember what the discriminant part of this is? What does that mean? Ethan?
Plus or minus.
Yep, so it's b squared minus 4ac. So why do we need the discriminant? What does it tell us? Why is it valuable? Thomas?
Tell you something about roots.
It does tell us something about roots.
So, like if it's equal roots, and they all have like an equal to 0 or like greater than 0.
Okay.
Less than 0.
So there's an option where b squared minus 4ac is greater than 0 or positive. There's an option where it's equal to 0.
Or no root.
Right, or less than 0, which means no roots. So if it's equal to 0, we have 2 roots or x-intercepts. If it's equal to 0, we have 1 root. Sorry, did I say equal to 0 on that first one? Greater than 0 is what I meant. And then if it's negative, I can't square root a negative underneath here. So you will notice that that means we have 0 roots. And I guess I don't need to say 1 roots. I can say 1 root. Okay, so the discriminant is nice for us to be able to just do a quick little prediction of how many roots we're going to get. And then if I have 0, then I actually don't have to even plug into the quadratic formula, right? and then I've saved myself a bunch of time. So that's why we like to kind of just do a quick little check with the discriminant first. You have to calculate it either way, right? We have to plug it into the quadratic formula to calculate, so we might as well just do it before we start plugging everything in. Zach?
So that sign being greater than the first 0.
This one is greater than, yes. So the first one, when we say greater than 0, we mean positive. And then for the last one, we mean negative.
Equals to 2 roots, and then if it's 0, it's 1 root, and then if it's a negative number, it's 0 roots.
Exactly.
Why can't we teach that last year?
Can I scroll from this?
Yep.
We're all good?
Easier.
Okay, so what we just want to make sure of is when we're using quadratic formula, we need it in standard form. So this one was vertex form. We talked about factored form yesterday. We want it in the ax squared plus bx plus c form. And it needs to be set equal to 0 because we're actually solving for where the x-intercepts are. So we want to set the y equal to 0 because along the x-axis, the x's all along the y-axis, the y's all along the x-axis are 0. All right, so here we go. Solve using the quadratic formula. This is where a equals 3, b equals 10, and c equals 8. And then plug into the formula above. Okay, my suggestion would be before you go and plug this entire thing into your calculator, you might just want to simplify underneath the root. So here we have 100 minus, what's that, 96, I think? Yep. Okay, so just doing, oh, sorry. I put 100 in the place where I wanted to put 10. Sorry, it's 10 squared here.
100 times 100.
Yeah, 100 times 100 is 100. No. And then we've got 6 on the bottom. Okay, and then before I put this into my calculator, I'm just going to simplify one more time. And actually, I don't think we even need a calculator for this because 4 is a perfect square. So 4 is just 2. We could actually just calculate this. So no calculator needed. Okay, so we're going to have two options. One of them will be negative 10 plus 2 over 6. And the other one will be negative 10 minus 2 over 6. Perfect. So no calculator needed for that. Negative 4 over 3 is actually the best way that we can express this because that's actually a repeating decimal when you put it in your calculator. So I would just leave it as negative 4 over 3 because it's more precise.
And you always reduce the fraction if possible.
Yes, always reduce your fraction if possible. Okay, so far so good. When we get a perfect square underneath this root, typically that means that this quadratic was actually factorable. So if you happen to get a perfect square underneath there and it said solve, you probably could have factored to solve, but we can also solve with quadratic formula. Yep, Thomas?
When you use quadratic formula or when you can't factor it?
Or discriminant?
Yeah.
So the discriminant is just to predict the number of x-intercepts that we're going to get. So for this one, we would have gotten positive 4 for b squared minus 4ac, and that just tells us that we expect to get at the end 2 roots. Yeah. All right. So Thomas, this is actually answers your question here. So for example 3, it asks us to first predict using the discriminant, and then it actually asks us to solve it. So this is where we'll first use, discriminant. So first things first, we're going to set our equation equal to 0 because we're solving for x-intercepts here. And then we're going to predict. So here let's just do A first. A equals -5, B equals 8, and C equals -3. So if we just plug into the discriminant here, eight squared is 64. And then we're going to get 20 times 3. Negative times negative times negative is a negative, so I know that this is going to stay negative. 64 minus 60. We'll get 4. Okay, this doesn't tell me we have 4 roots. What does this tell me? Because it's positive, we have 2 roots. Okay, and then we're going to find the X-intercept, so we're going to solve. So because we're just practicing with quadratic formula here, we'll use quadratic formula. You guys like to make your life easier?
No.
I hope no one says no here. So you guys already calculated b squared minus 4ac above, right? So we're just going to plug it in here. We're not going to recalculate it. Doesn't make sense, right? We don't want to make our lives harder or cause ourselves more work. I'm actually just going to plug in the 4 right there. We already calculated it. And then we'll do 2 times a. Okay, so one of them is going to be the plus option. The other one, it will be the minus option. Oops. Let's do it below. Okay, this one's going to give us -6/10. So when reduced, -3/5. Or no, +3/5. Now because, oh, yeah, go ahead. X1 and X2. So it just means like the first X-intercept and the second X-intercept. And it doesn't matter which one is which. We're just saying like one of the X-intercepts is this and the other one is this. Okay? If you guys want, because we're graphing this one, like we're actually going to sketch the graph of this, you can calculate 3/5 as a decimal just so you can place it. That's for lines. Yeah, that's just for slope of lines. So this is, what, 0.6? Yeah. Okay, so these are our X-intercepts. The question also asks us to find the axis of symmetry and find the vertex. Okay? If I have my X-intercepts, does anyone remember how we can find the axis of symmetry from those? Josh? Yeah, so we're like almost finding the center of them. So like if I want to find the average of Thomas's mark and Olivia's mark, I'm going to take their marks together and I'll add them and divide them by 2. And then I'll get the middle of both of those marks. So same thing with your X-intercepts. Your vertex happens halfway between that. I want to take them, add them, and divide them by 2. Okay? So axis of symmetry is 0.6 plus 1. All over 2, and I believe we get 0.8 from that. So your axis of symmetry is actually also the x-coordinate of your vertex. So if I know the x-coordinate of my vertex now, how do I find the y-coordinate? Josh? Yes, we're actually going to plug it back into the equation above. Shh, guys. Okay, so we are going to evaluate for this last part h at 0.8. Okay, I'll get you guys to calculate that for me. Okay, so just plugging it into this original equation here. For you guys, it is not next week, but the week after the Tuesday of that week, I think. Or no, for you guys it will be the Monday, I'm pretty sure. Actually, no, you guys are the Tuesday. Sorry. Final answer. What'd you guys get? Yeah, that sounds familiar. All right, so our vertex is at 0.8, 0.2. And I'm going to box that up as well because that's one of the points that we're going to graph below. Okay, so when we go to graph this, I'm probably not going to go by ones on my x and y axis because I have to graph things like 0.2 and 0.6 and 0.8. So I think we can go up here by, yeah, if we go up by 0.1s, I think that would be good. Or you can just skip every other one and do like 0.2, 0.4, and so on. Okay, and I'm actually going to do the same thing on the y-axis. Yeah. Okay, so we're going to graph our vertex, we're going to graph both of our x-intercepts, and then we're going to show where the axis of symmetry is here. So x-intercepts are at 1 and 0.6. Vertex is at 0.8, 0.2. Okay, and then we have an axis of symmetry that we can show here. It's x equals 0.8. Does it make sense that this quadratic should be opening down based on your original equation? Yeah. Yeah, the a value is negative in the original equation, so that should make sense.
What does the a value mean? Like the amount that it would open outwards?
Yeah, it's kind of like a, we're going to learn actually a little bit more about what that actually means, but the negative part means it gets flipped, and the 5 part actually means it gets stretched. So we'll see how we can kind of like determine what that is. We're going to learn about that in 2 units. Good question. Okay. Are we all good with this one? Yep. Zach?
0.6 and 0, let's just say, because they're both on the 0. Like, yeah.
0.6 and 0, yep. For y. Yeah, so if we were actually like, this point is 0.60 and 1, 0 when we think about x-intercept. All right, and then I just want to take a look at what is going to happen if you don't use the discriminant. Let's say you weren't checking ahead of time, you weren't using b squared minus 4ac. If you were to go and say, okay, 0 equals x squared minus 6x plus 11, and then plug right into your quadratic formula, what's going to happen? So our a equals 1, our b equals negative 6, and our c equals 11. So let's just say we plug into this. Okay, be careful when you plug in a b value that is negative, especially when you do this squared part right here. You need to make sure that you square the entire negative part. So if I were entering it into my calculator, I'd make sure that I enter it in with brackets around it. Otherwise, my calculator doesn't know whether it's 6 squared and then a negative in front or the whole negative 6 squared. Okay, so what's going to happen is negative and negative here will make positive. And then we're going to get 36. 4 times 1 times 11, that's 44. And then we're going to see this. 6 plus or minus negative 8 over 2. Now, if you try to plug this into your calculator, okay, especially this part, you can just try that part by itself. What happens when I try to square root negative 8 in my calculator? You're going to get a math error, right? So at this point right here, you can actually visibly see b squared minus 4ac is negative. That should tell us that we have no roots, okay? So you can't square root a negative. Okay, so we'll say, therefore, no roots. Okay, before I decide that there's no roots, I'm going to go back and check my work here and make sure I've done that correctly. And if I'm confident about it, then I will decide no roots. No, I was just pointing like this. You just happen to be over there.
What would that look like on a graph? Like a line?
So cases where this can happen can either be if your quadratic is like above the x-axis opening up or below the x-axis opening down. Yeah. Good? Okay, this is why plugging into b squared minus 4ac is nice to do as an initial step, just because then I don't have to plug all the way into the quadratic formula just to find that I have no roots halfway through.